Okay, let us see the illustration. First question. Question number 1 on the electromagnetic radiation. We'll see. Find the ratio of frequencies of find the ratio of frequencies of violet light. They are given the lambda 1 for this violet light is 4.10 into 10 power minus 5 centimeters to that of red light, to that of red light. So violet light lambda 1 value given, red light lambda 2 value given for the red light, that is equals to 6.56 into 10 power minus 5 centimeters. Also determine the ratio of energies carried by them. Also determine the ratio of energies carried by them. Okay, this is the problem we have. So they are asked about the ratio of frequencies. We know that what is the frequency and wavelength relation. As you know that mu is equals to c by lambda is the general formula. From this general formula, we can understand that relation between nu and lambda is inversely proportional. So what is the meaning of this one? Nu1 is proportional to 1 by lambda 1 and nu2 is proportional to 1 by lambda 2. Once they are asking the ratio of frequencies means what will happen about nu1 by nu2? Yeah, you can write nu1 by nu2 is equals to lambda 2 by lambda 1, right? What is lambda 2 given in the question? That is 6.56 into 10 power minus 5 centimeters divided by 4.10 into 10 power minus 5 centimeters. So these 10 power minus 5, 10 power minus 5 get cancels. And rest of the other thing is nothing but 656 by 410. 656 by 410. If you check the simple calculation answer for this one, 656 divided by 410, exact answer is 1.6. So the ratio is 1.6 value. Or also you can write this is nothing but 16 by 10. 16 by 10. Or it can be written as 8 by 5. 8 by 5. So what is the ratio between nu1 and nu2 frequencies is nothing but 8:5. This is the answer for the first question. The first question answer, that is the ratio of frequencies were calculated, that we got. This is the first question answer. The next question they asked is also determine the ratio of energies. The ratio of energies carried by them. As you all know, the energy E, according to quantum theory, proportional to frequency. When the energy is proportional to frequency, you can call this E1 proportional to nu1 and E2 proportional to nu2. Now, what is the ratio between the E1 and E2? That means E1 by E2. E1 by E2 will become equals to nu1 by nu2. What is the nu1 value we have? That means 8 by 5 That is same only. Again, the answer for the ratio of frequencies, ratio of energies remains the same. That is E1 is to E2 is equals to 8 is to 5. That means we have got the same answer. Why? Because here energies are directly proportional to frequency. Once we got the frequencies ratio, the nu 1 is to nu 2 is nothing but frequencies ratio. That is same as that when we got the ratio between the energies. That means the ratio of energies carried by them is also the same. This is the most important illustration we have observed for the board examination as well as the competitive examination. Okay, so I hope you understand this one. Like this, most interesting questions we'll discuss in the next coming sessions. Until, have a nice day. Bye bye. Okay, let us see the next problem. That is a 100-watt power source. A 100-watt power source emits green light. Emits green light at a wavelength. Lambda is equals to 5000 angstrom unit. 5000 angstrom unit. Then how many photons per minute? How many photons per minute emitted by the source? Emitted by the source. So it's a very interesting question. Actually, in this question, they have not directly given the energy, but they given the information about the power source about 100 watts. Actually, what is power source? Watt is nothing but joule per second. Joule per second, that means joule per time, that is second. This power source joule per second can be substituted, that is nothing but as total energy, that is equals to 100 joule per second. Okay. Not only that one, that lambda value they are given is equals to 5000 angstrom units. You can convert the angstrom units into meters. That is 5000 into 10 power minus 10 meters. It will become 5 into 10 to the power of minus 7 meters. We can convert like that. Not only that one, the time in seconds is 60. 1 minute is equals to how many seconds? 60 seconds. When you want to convert this power, that is equals to energy is equals to power into time, then what will happen? This can be multiplied with this 60 seconds. That means total energy in joules should be obtained by multiplying 100 with 60. Then second will get cancelled. You will get 6000 here. In this, you get 6000 joules. Okay. Now coming to the point, C value that you know, that is 3 into 10 to the power of 8 meter per second. That is velocity of light. In this juncture, you need to find what is hc by lambda. What is hc by lambda? H value already we know that is 6.625 10 to the power of minus 34. C value 3 into 10 to the power of 8. Divided by lambda I got is 5 and 10 to the power of minus 7. First we would find the value exactly, that is 6.625 into 3 divided by 5. How much? That is 3.75975. That is 3.975 is coming. This is 10 to the power of minus 26. Minus 26 plus 7 is 10 to the power of 7. So 10 to the power of minus 19 will come here. Is the answer. So point is very clear that you want to find the number of photons. The formula is total energy is equals to NH nu, nothing but NHC by lambda, N into Hc by lambda. So total energy is equals to N into Hc by lambda. N is number of photons, that is equals to total energy by H into C divided by lambda. We have the total energy value. The total energy value we got is 6000 joules divided by the 3.975 into 10 to the power of minus 19 joules. So joules will get cancelled, and we'll be seeing the value, the number of photons once 6000 is divided with 3.975. So 6000 by 3.975 is exactly 15,159. So 1509.443 coming. So you will take the 4 digits only into 10 to the power of 19 coming. So you want to convert this one as 1 point only. So 1.509 into 10 to the power of 22 photons. So in this, there is a strategy we applied. That strategy, in that one, energy given by power source in t seconds is P into T. So directly you can write that total seconds, time in seconds, and directly you can multiply 100 joule per second. All this, you substitute in this formula, you will get the right answer. Okay. So power source given in the problem can be written as, and that is energy, and that energy we got 6000 joules. Okay, see the next question, that is how long would it take a radio wave of frequency? How long would it take a radio wave of frequency? Radio wave of frequency 6 into 10 power 3. 6 into 10 power 3 second inverse to travel from Mars to the Earth. Mars to the Earth. A distance of 8 into 10 to the power of 7 kilometers. 8 into 10 to the power of 7 kilometers. This is the question they have asked. So in this question, we have to find the time interval. That means how long would it take a radio wave of frequency 6 into 10 to the power of 3 second inverse. So very clearly they are given the frequency, that is a new value they are given the question. And another one, which is travel from Mars to Earth, distance given, that is Time is nothing, time, distance and this velocity. The interrelationship is nothing but time is equals to distance by velocity. What is the distance given here is 8 into 10 to the power of 7 kilometers. That can be converted into meters. That means what is the distance value given in the question? Distance value D is equals to 8 into 10 to the power of 7 kilometers. That can be converted into meters by multiplying this one with 1000. That will become 8 into 10 to the power of 10 meters. This is very clear. But we know that velocity of the electromagnetic waves is equal to the velocity of light. That means what is the velocity? That is equals to 3 into 10 to the power of 8 meter per second. Meter per second. Okay. Or you can write like this. Now velocity came, distance came in the discussion. Now what is the time formula? Time is equals to distance by velocity. Distance by velocity. So what is the distance given in the question? That is that I am substituting here. That is 8 into 10 to the power of 10 meters divided by velocity, that is 3 into 10 to the power of 8 meter per second. Okay. So this is 10 power minus 10 power 10 minus 8 is 10 square. 8 by 3 value is 2.66. This is 10 square. So 2.66 into 10 square seconds is the distance traveled. The time to travel a frequency of 6 into 10 to the power of 3 second inverse. So that means they are given the frequency value, and this value we have not at all used anywhere because they asked the time interval. Time interval can be deduced from the distance and velocity because time is equals to distance by velocity, and that distance velocity values are substituted with the same units, and then we got the final answer in seconds, time answer in seconds. So how long means you have to find the time. So time we have calculated, that is 2.66 into 10 to the power of 3 10 to the power of 2 seconds means 266 seconds. We can understand this is nothing but 260 seconds is the answer for this question. Let us see the next question. A quanta of light having energy, a quanta of light having energy capital E has a wavelength equal to, has a wavelength equal to 750 nanometers. 750 nanometers. So they are given that wavelength in this question. Find the wavelength of photon. The question is find the wavelength of photon that corresponds to energy 5E. That means 5 times of the first one. 5E. That is the question. So once again, if you observe the question, a quanta of light having energy E. This is the energy of that quanta, packet of energy, has a wavelength value given, lambda value given for this one. Then find the wavelength of photon. We have to find another wavelength of a photon that corresponds to energy 5e. That means 5 times of this first one. So we have two energies relation. That means when you have taken the first one as A, quanta A, its energy E1 can be written as E1 is equals to hc by lambda 1. The second one you can write as B. B is the quanta, that is E2 is equals to hc by lambda 2, that is equals to 5e, 5 times of the first one. Okay. Now, if you divide these two things, then we can find lambda 2. What is the lambda 2 value discussion is when you find E1 by E2. What happens? Lambda 2 will come reverse. So, E1 by E2 is equals to, what happens? It will be lambda 2 by lambda 1. And coming to the point here, from this what is lambda 2? Lambda 2 is equals to E1 by E2 into lambda 1. And the point is very clear that they have given the lambda 1 value is 750. So what is the lambda 1 value given in the problem? That is 750 nanometers. We don't know lambda 2, and they given E1 value is E and E2 value is 5E. If you substitute these things, E1 is E and E2 is 5E into 750. So E will get cancelled. 750 by 50, 15 times of this 5 is 75. So it will become 150 here. That is 150 nanometers. So lambda 2 value is 150 nanometers. That means find the wavelength of photon that corresponds to this 5E is 150 nanometers is the answer for this question. Hope you understand this question very clearly. We will see the next question. See the next question. That is electromagnetic radiation of wavelength 242 nanometers. Just sufficient to ionize the sodium atom. Calculate the energy of sodium, ionization energy of sodium in kilojoules per mole. Only one thing they are given, that is lambda value given. Lambda is equals to 242 nanometers they are given. That can be converted into meters. That is 242 into 10 power minus 9 meters. You know that velocity c is equals to 3 into 10 to the power of 8 meter per second. Okay. Coming to the h value, h is equals to 6.625 into 10 power minus 34, 10 power minus 34 joule second. Moving on to the other things here, we have to find the energy in this discussion. That means the energy E is equals to hc by lambda, h nu. So the formula for the energy calculation, E is equals to, I'll write here, that is E is equals to hc by lambda. I'll substitute here that h value is 6.625, c value is 3 into h value 10 power minus 34 and 3 in 10 to the power of 8 means it is plus 8 divided by that lambda value. What is the lambda value? That is 242. 242 into 10 power minus 9. Okay. So let us see the simplification here. Upon simplification, we have got this one as this is we are writing as 10 power minus 19 joules. This is the rest of the other part has become 8.21. Okay, you can check the simplification calculation. So the calculation answers came like this. That means this is the value for atom, for one atom. That means for one sodium, this is the energy is required to remove the electron. That means ionization energy means how much energy is required for the removal of electron from the atom. But here, calculate the energy in kilojoules per mole they are given. We know that 1 mole is how much? How many sodium atoms in 1 mole of sodium means? What is the number of sodium atoms? That is 6.022 into 10 to the power 23 sodium atoms. So 1 atom, this is the answer. Want to find the ionization energy of sodium, then the ionization energy of sodium in kilojoules per mole can be calculated by multiplying the 1 sodium atom joule energy value into Avogadro number. That is 8.21 into 6.022 into this is 10 power 23 minus 19. 10 power 23 minus 9. This is 10 power 4. So I will check the calculation answer. That is 8.21 into 6.022. We got 4944. 49.44 we got 0. 62 we got 062 we got. So I am writing 4 digits of this decimal into 10 power 4 means you can write this is 49.4. This point I am removing, that is 494406 joules per mole. So this is a big value. You want to write this one in kilojoules also, you can write by dividing this one into 1000. So you will get 494.406 kilojoules per mole is also the answer for this question. Hope you understand. In this question, first we have noticed what is the lambda given. The remaining things we have taken, that is velocity, h value, and using the hc lambda value, we have calculated the first discussion, that is energy, and that energy actually is energy per atom. After that, we came to the discussion, that is a problem. They asked the ionization energy in kilojoules per mole means Avogadro number of sodium atoms we have to take. So the Avogadro number is multiplied with the number of sodium atoms multiplied with this 1 sodium atom energy. We got the ionization energy is 494.406 kilojoules per mole is the right answer for this question. Hope you understand this question. That was actually